Start up on 6.1, I want you to look at page 156 of your student journal. Okay, I want you to take a couple minutes to define as many of those words as you can, based on what we talked about yesterday and what you knew from the previous. Okay, a couple minutes there. All right, so an exponential function. So we talked yesterday that's in the form of f of x equals b to the power of x, where b has to be greater than 0, or b has to be greater than 0, like that. Exponential growth function. Okay, when we're dealing with an exponential growth function, you have f of x is equal to b to the x, and b is greater than 1. Okay, and then a growth factor. Remember, b is our growth factor. All right. It's also our decay factor. Okay. So if we go down to exponential decay function, that's f of x is equal to b to the power of x. However, it's when b is less than 1, but b is greater than 0. Smush that in there. So it's in between 1 and 0 there. Okay. And once again, b is our decay factor. And we're going to break apart b here in a while and see that it's made up of other things. But okay. All right. Remember, a growth factor does this. It increases from left to right. It approaches a line. Yesterday it was approaching the x-axis every time, but it won't always be that line. Whereas the decay factor decreases. Unbelievable. Decreases from left to right. And also, yesterday it was approaching that line. That line it approaches but never crosses is called the asymptote. Okay, it's a line that your graph approaches but will never cross. Okay, that is your asymptote. I believe that stuff is laid out in your student journal in the next couple pages, maybe in a bit different format. Is that true? Or I guess on the bottom there you get some of that, and you have the definition of the asymptote. Okay. All right. And on the next page, it talks a little about the decay function. Try to. Yeah. Okay. Any questions there? All right. There's one other piece that we haven't talked about, and it's called compound interest. Okay. You covered this a little in Algebra 1, but compound interest, I am going to try to tie this to our growth factor. Compound interest is a growth function. So if we think of our function y equals b to the power of x, what you studied yesterday. Okay, you guys, this is going to get pretty deep here in a minute, and so you want to make sure that you're taking some notes and just not trying to pick it all up in your brain there. Okay. All right. Really, there's another number. There's another letter out in front of this, b. We call that a. We don't show it. So right now, a is always 1. Okay? A just happens to be our starting amount, or our initial value. So, bless you. So really what we can do, this a and this a, by the way, are different. This a stands for the amount a. Okay? So here we're dealing with specifically like money. Okay? This stands for principal. Okay? The principal deposited. The amount initially deposited. This R right here stands for our annual rate, our annual interest rate. What does annual mean? Good. N stands for the number of times compounded per year. And T, by the way, that N and that N are the same. T stands for number of years. Okay, so we have a lot of different stuff there. What I'm going to do is I'm going to make this look more like that, or describe how they're the same. First, Y is easy. Okay, rather than calling it Y, we call it A. Why? Because the A is our dependent variable. The amount depends upon your rate, your time, and the number of compounding periods. So therefore, this just becomes that. Okay. So if we were looking at it, we can easily see how that drops into that, and P actually becomes our A value. Not, remember, these A's are different. This is our initial amount. Okay. What changes though is what's in parentheses here. All of this stuff inside parentheses is our B value. And this stuff on the outside, our power up here, that is our X. Okay, so really describing this, B is, we've said that B is our growth rate, right? It's our, if you looked at your previous page, we call it our growth factor. Okay, we're going to break that B up. So if you, let's take for instance, you go into the bank, okay, and you say, okay, bank, I have $400. Actually, let's say, just for the sake of this problem, let's say $500. I have $500, bank. That is my initial amount. What do we call that? Our starting amount we're calling? That's our principal, right? Okay? So P is our principal. Okay? We are starting with that. Okay, bank, I have $500. I want to earn some money on that $500, so I'd like to put it in your bank. And the bank goes, good. And you say, okay, what are you going to give me for keeping my $500 in the bank? What they give you is interest. And banks offer different interest rates. And they have different compounding periods. For instance, my bank offers, it compounds 4 times a year. We call that quarterly. There are 4 quarters in a year. Okay, we call that, so we say it compounds quarterly. If we said semi-annually, that would be twice a year. If I said biannually, same thing, twice a year. If I said monthly, that would be 12 times a year. Okay, so let's say the bank goes, okay, we are going to compound quarterly. So N would be quarterly, that means N equals 4. There's 4 compounding periods per year. It means every 4 months, I would get interest. Or excuse me, every 3 months I would get interest. Right? 12 months divided by 4 is every 3 months. So, the bank says, okay, I'm going to take your $500. And by the way, they don't just stick it in a safe and let it sit there. They use that money and invest that money. That's how they earn money. Okay? So they're using your money, right? To use your money, they are paying you interest. Now, a bank, when you do this, if I have Y equals, in this case, actually it's no longer Y, it's my amount. If my amount is equal to my $500 times, notice this says 1 plus RN. That 1 right there is a big deal to you. That is telling you the bank says, hey, no matter what, we are going to start at $500 next time you come in. Okay? And the even bigger deal for you after that is that. Because that plus means we're going to start at 500 and we are going to add to it, not deduct from it. Right? Like if you give them $500 and you come back and there's only 300, you're like, dude, what happened? Sorry, man. You lost money. That's a bad bank. Okay? You're like, hey, you get 100% of your money back. So why isn't this 100? Tell your neighbor, why isn't that 100 rather than 1? Okay, time's up. Hey, it comes down to some wording. The word 100%, the word percent means per divided by cent is 100. That means 100%, which is 1. It's decimal form. Yeah, I know you know how to work with percents and decimals, but that's what that means. That's why we divide by 100. So when we calculate this stuff in terms of rates, we go to decimal form. So this is saying, hey, dude, you get 100% of your money back plus we are going to give you a rate, a certain amount. Okay? So let's say that this bank says, you know what, we're going to give you 4%. Okay? 4% interest. Annual interest. Your annual rate, can you guys see that? Is 4%. You're like, score, dude, I get 4% per year. That means on my $500, simple interest would be, hey, 1% of 500 is 5. So I get how much? $5. 5 times 4 is $20. I get $20 a year. That is called simple interest. That was pretty simple to calculate. That is not compound interest. Simple interest says, hey, simple interest is they compound it once a year, which really isn't compounding it. Okay, that's simple interest. Okay, you get $20 a year. Compounding interest says, okay, we're going to take this rate and we're actually going to break it up into the number of times it compounds a year. So this rate is actually not 4%. It's, what is it? It's 4 over 100, or as many of you said, it's that. Yes? No. What'd I do? Good. I added an extra 0. Okay. Just want to make sure you're paying attention. It's that, yes? Okay. All right. So, how many numbers behind the decimal? 2. How many zeros? Coincidence? I think not. Okay. All right. Very good. So, this right here is my rate. And they're saying every time you compound, we're going to give you a part of that rate. Well, it's pretty easy right here, right? Because we're compounding 4 times a year. So what am I getting every compounding period? What percent? I'm getting 1%, right? If I take 4% divided by 4, I get 1. So every 3 months, they're giving me 1% of my money back. So in 3 months, they're going to give me $5. And 3 months from there, they're going to give me another $5. Well, it won't be 5. It'll be a little over 5 because now it's building. The first time, just really quick so we'd see how this would build, when time is 0, okay, at the very beginning, I get 500. At my first compounding period, I am now up to 505. In my second compounding period, I am now up to, okay, multiply this by 1%. Okay, so I'm earning interest on my interest. Okay, so what is 1% of? Yeah, it'd be $5.05. So now I'm up to $5.10 and $510.05. Now, for some of you, you're like, whatever, dude, you got a nickel. Okay, well, what if it's your retirement? Okay, that's a big deal. What if maybe it's another investment? Maybe it's $1.5 million. Okay, maybe you are investing in the stock market and it's not 1%. Maybe it's my retirement. Right now in my retirement account, I think I have like $130,000 in part of my retirement. Okay, so if I'm taking that and I say if I take 130 and on my investments, I get 15%, and they compound that 4 times a year. That means I'm getting, well, let's say I get 16. It makes it easier. That means I'm getting 4% every 3 months. And the next 3 months after that, I'm getting 4% of the compounded amount. So they're taking a chunk, adding it to this, and then I get money off that investment. That's compounding interest. By the way, that's how credit cards work also. That's why you want to avoid credit card debt if you can. Because that's how you end up owing more as well. That's an investment for the credit card company, is getting you to owe. All right. So this right here, we now have in. We're going to keep this investment in for the time in the bank in terms of years. We're going to keep it in there for 10 years. Why? Because we plan ahead. Okay? We don't have anything we're doing in the next 10 years. So that 500 is just going to sit around for 10 years. Maybe your grandma gave it to you and you plan on using it for down payment on a house or something. Or partial payment, because you're not going to get much of a house here. But, okay, but $500, 10 years. You go, hey, number of times per year is still 4. That's that in. And times 10 years, that means it's compounding 40 different times, right? 4 times a year for 10 years. This will tell you what you get after 10 years. I want everyone to calculate how much money you have earned or how much money you have in that account after 10 years.
Are you? I don't think you are.
Not really.
What's that?
$744.
Okay, we have one person that says 744.
Yeah. 744.
Yeah?
43.
Oh, 0.4. Good. Yeah, so you've earned $244.43 for just letting your money sit there. You haven't had to do anything other than think, man, I wish I had $500 in there. Okay? That's it. That's over 10 years, dude. You just forget about it, you know? All right. Everything comes back to something. All right. All right. Hey, any questions there? Hey, guys, compound interest can be very confusing. I'm trying to make... Does everyone understand how these two relate? Okay. All right. I want you to take a look at page 158, please. Student journal. On page 158, I want you to complete problem 2, problem 5, and problem 6. 2, 5, and 6, please. Okay, you work with your groupie there. As you're completing your graph, please keep in mind you should not be using your calculator to complete a table of values. You should not be using your calculator to complete the graph. And then the other piece that you need to keep in mind, what type of, is this growth or decay? It's growth. How do you know?
Greater than 1.
B is greater than 1. Okay? So as you're completing that graph, you need to be able to see the curve in the graph. So for instance, if I say, okay, I'm going to plug in 0, what do I get out? I get 1 out. So I put 0 in for x, I get 1 out. Okay? I'm going to plug in 1, I get 1.5. So remember, if you don't number your lines here, then you define your scale as going up by 1. If I put 2 in, I get, now here, if you needed a calculator, you could use it, but hopefully you know 15 squared is 2.25. Now, usually, hey, 3 points, am I good? Well, the question is, can you see the curve? No, so you're not good. Okay, we now have to put 4 in. 1.5 to the 4th. Or is that 3? 3, excuse me.
About 3.375.
3.375-ish?
Yeah.
How about 4? Okay, so about there. We're starting to see a curve. Let's do -1. It's like 2/3, isn't it?
Yeah.
Okay, you kind of see the curve there. I think we're probably good there, but if you wanted to be safe, you could put in -2 and calculate that as well. You'd see that it starts approaching the line y equals 0. Okay? So just make sure you put those in there. 5, I want you guys to complete number 5 if you haven't done so. Growth or decay? That is growth. How do you know? B is greater than 1. Okay, growth. Hourly percent increases. Okay, you always start at 1. And from that 1, what are we doing? We're adding 0.99. Therefore, it's the percent increase is not 0.99. That becomes 99%. Okay? Yeah. That's almost like a 2, meaning 200. Yes?
Okay.
Yeah, if you had like 1.89, that would be 89% growth. Oops, 89%. Okay? Pretty much, yeah. Hey, by the way, what if you had 0.72 right there?
Oh, that's negative 38.
You're subtracting 28,
Not 38.
right?
I'm sorry, I saw this.
You're going down from 1, you're going down 0.28, which is 28%, and that would be decay. Because you're decreasing. You always start at 1, so you either increase from 1 or decrease from 1. Okay? What's that? You always start at 1. So 1 minus 0.28 is 0.72. Okay? Estimate the number of bacteria when it'll be 1 million. Well, remember, they're measuring in thousands here. So rather than, like if you write your equation like this, thank you. If you write your equation like that there, and we plug in 1 million here, remember they're saying y is in terms of 1,000. So get rid of 3 of those zeros for 1,000. 1 million is 1,000 thousands. So you're saying when is y equal to 1,000? Because 1,000 thousands would represent that 1 million. Okay, to solve that, you have to divide by 100, which gives you 10. And 1.99 to what power is 10? That's where you're kind of using some guessing and checking, man. Right? Because, unfortunately, you don't know how to use logs yet, and that's what you would use a log for. That's why we study logs, so we can get the variable out of that power position. We make it less powerful. It's like kryptonite, dude. Okay. Where did I get what? Because we're dealing in thousands here. So when they say 1 million, that's 1,000 thousands. You just drop 3 of those zeros. So it's 3.35-ish. You have to do some guessing and checking. You have to put in... What's that? 3.4? That's okay. That's pretty close. If you know logs, it's easier to figure out. But here you're just going to have to guess. You put in 1, it doesn't work. 2, 3, you're like, ooh, I'm getting closer. 4, nope, I'm over. And then 5. Okay, well, you don't want to do 5 because 4 was over. So 5 is going to be over. So you decrease from there back to 3. That's why we like logs. It's a lot faster. We'll do them later this chapter. It will be easier. How many have finished number 6? Okay, give you a minute to do number 6. Use your compound interest. Here we go. Hey, I'm going to put on my work here so you can see it. Now, my work got a little messy because I messed up on my decimal form to begin with. So, let me point a few things out. First, the function a equals p, or the formula a equals p times 1 plus r over n times n, or to the nt power. P is 1250, that's our principal. R1, and then we have 0.0225. Now I had put 0.025, I forgot a 2. Oh, thank you. Alright, so we got 0.025 or 225 here. So to make this a little more clear, this is actually 1,250 times 1 plus 0.0225 over 4, all to the what power? The 20th power. I ran out of room there. Fix it up. Okay, did everyone get 1398.40? Yeah, man. If you didn't, please talk to me so we can figure out what you're doing incorrectly there. All right. Hey, any questions? All right.